So we want to simplify this expression and give it an exact form. Remember, an inverse trig function, arctan here, represents an angle. So what I have is cosine 2 theta, a double angle. So I'm going to use the double angle formula to express this in terms of just a theta instead of a double theta. And so I've got three different forms for this, and I can use whichever one I want. So I think I'll use the original form, which is cosine squared theta minus sine squared theta for the double angle. Then I'm going to draw a triangle, and this inverse tangent is -2. So we know inverse tangent would be an angle in quadrant 4 or quadrant 1 because it runs from -pi-halves to pi-halves. So the negative is going to be here in quadrant 4, and I'm going to label this triangle then so that when I look at this angle that the tangent here is -2. So I'm actually this angle, and this is my reference angle. And so tangent is opposite, which is -2, over adjacent, and I can always make any number a fraction by putting it over 1. Now if I want to find the hypotenuse, I can take each of the legs squared and sum them up and square root them, and that's going to mean the hypotenuse is the square root of 5. Now I'm ready to go ahead and answer my question. I need cosine of theta. Here's my triangle. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse, but I need to square that. And then minus, I need the sine, and the sine is going to be opposite over hypotenuse, which is -2 over square root of 5, and it's supposed to be sine squared, so I'm going to square that. And now let's do some simplifying. This is going to be 1/5 minus 4/5. So my final answer is going to be -3/5.